Hello students, welcome to the e-learning platform presented by Mechanical Engineering Department of Dr. Bapuji Saroke Institute of Engineering and Technology, Kolhapur. The learning objectives for today's session are: number 1, study of chassis, frame and body. What do you mean by chassis? How chassis is designed? Types of chassis will be studied in today's session. And study of frame. What do you mean by frame? The parts mounted on a frame, types of frame will be studied in today's session, and the function and the requirements of chassis and frame will be studied in today's session. Starting with first, chassis, frame and body. Chassis is a French word used or was used to denote the frame parts or main structure of a vehicle. Vehicle without its body is called chassis. Chassis is basically the backbone of vehicle and made up of steel, and all moving parts are fitted to the vehicle. All the major units required to propel the vehicle or that give the motion to the vehicle, stops the vehicle, permits smooth running over the varying surface is known as chassis. The chassis consists of following equipment such as frame, steering mechanism, front and rear end suspension, transmission system, engine, clutch, gearbox, propeller shaft, differential, fuel tank, hydraulic pipe, cable, silencer, storage, battery and electrical systems. All these are folded on a chassis. Next point, frame construction. The frame is the main part of the chassis on which other automobile components are attached, such as the other components attached on a chassis. Frame is main part of chassis on which other automobile components are attached. It is rigid, strong, it supports the weight of vehicle, withstands the stresses, shocks and vibration encountered on the road. It consists of two symmetrical beams, rails or channel running all along the length of the vehicle, and cross member connecting them. The frame is usually made up of box or tubular channels or U-shaped section welded or riveted together. Figure below shows represent the frame longitudinal member and cross member. The frame is upswept at rear and front to accommodate the moment of axle due to springing. The frame taper from the rear to front permit adequate movement of steering wheel to give smaller turning circle and steering lock. The frame or the tubular box section cross member provides support the body and increase the torsional rigidity of the frame. They also increase bumper brackets for mounting the spring. The construction of frame is box shaped tubular or steel members welded together is known as ladder frame arrangement. The complete frame is fabricated by the welding process. Commercial vehicles have heavy loads and frame construction is invariably used because in this ground clearance is larger and sufficient space is available for steering the vehicle or steering the wheel. So in the commercial vehicles the frame construction can vary as per the need. Functions of chassis, frame and body. The main functions are as follow. Number 1, to support the vehicle components and body. Second, to deal with static and dynamic load without undue deflection or distortion. Third, to sustain the weight of body, passenger and cargo loads. Fourth, vertical and torsional twisting transmitted by going over uneven surfaces. Transverse lateral forces caused by the road condition, side wind and steering the vehicle should also be withstood by the chassis frame body. Torque from engine and transmission, tensile forces from acceleration as well as compression from braking, sudden impact during collision and reduction in body weight to increase the capacity and fuel economy. These are the functions of chassis, frame and body. Next point is requirements of chassis, frame and body. What is the requirement of an automobile body is the question asked in previous examinations. The first, space availability. Space availability, there must be adequate space inside the body for passenger and luggage or both. Second, stiffness. The car body may be considered rigid beam which is supported on wheels at each end. The car body must have sufficient stiffness to prevent sagging or bending in the middle. Third, strength. The body must be strong enough to withstand all types of forces which the car is subjected to, including the weight of the vehicle, weight of passenger, weight of luggage, inertia forces and side forces. It should also be able to withstand or withstand the side load or impact loads of a reasonable magnitude. Fourth, protection against weather. The design of body may be such that the occupants and luggage are protected against the weather. Torsional stiffness. The body should be perfectly rigid so as to resist twisting moment on rough roads. Protection in accidents. This is important parameter in designing of car body, chassis, frame. The body must be such that the driver is at maximum ease so that there is least chances of accident taking place due to fatigue. However, in case accident taking place, the body must protect the occupants. Airlift or drag. It should be the resistance of air during running depends upon the body shape and size. It increases directly with vehicle speed. The shape of body should be such that the air drag should be minimum. And resistance to corrosion. The vehicle body is exposed to corrosion throughout the life. The body should be designed such that no moisture is accumulated which causes rust. The materials are used also be such that no corrosion takes place. Next point, loads on chassis, frame or chassis and frame. The various types of load acting on chassis frame are shown in the image below. The first one is a short duration load. Short duration load, while crossing a broken patch of road, vehicle acted by heavy and suddenly applied load for short duration. Second, momentary load, that is while turning a curve, during braking, sudden striking at a pothole of a vehicle, obtained upon by combined load for momentary duration. Third, impact load. Impact load is due to the collision of vehicle with another object. It is subjected to externally applied impact load. Fourth, inertia load. During the application of the brakes, the inertia load of short duration are applied on the vehicle. Fifth, static load. Load due to the chassis components such as engine, transmission system, suspension system, braking system, steering system, fuel supply system, passenger, etc. are constantly acting on a vehicle. Overload. This is overloading of vehicle is loading the vehicle beyond the design capacity. And last, the upward twisting forces caused by the road shock which cause the torsional effect. So torsional load or bending load must be also taken up by the frame. The various types of frame or frame construction. There are basically two types of frame construction as shown in figure below. Number one is conventional pressed steel, also known as non-load carrying frame. that is non-load carrying frame, and second, mm, unitized construction also known as integral frame or frameless construction. These are the two types of frame construction. Starting with first, conventional pressed steel frame. Conventional pressed steel frame, also known as non-load carrying frame, is supported on wheel axle by means of spring so that loads on the vehicle are transferred to the suspension system entirely by a separate chassis. In this case, the body is either being made of very flexible material or being made stiff. The body is isolated from chassis deflection rubber mountings. In this case, vehicle loads get concentrated round the mounting and hence result in early failure. This construction has almost disappeared in case of cars nowadays. The below figure shows non-load carrying frame or conventional pressed steel frame. Here the all mechanical components are attached to it and body is superimposed on it, that is the body is welded or riveted on it. This type of frame is used in commercial vehicle and preferably in a large expensive private and open cars. The body work is made of material like wood and other material. The body is completely isolated from frame deflection. This type of frame is not suitable to resist the torsion. There are types of frame design such as C-shape, or the frame design used in these frames are basically C-shaped frame, boxed frame and hat frame. The second point or second type of construction is unitized construction or integral frame or frameless construction. Unitized construction, also known as integral frame or frameless construction, is used mostly in cars. Below figure shows the integral frame or frameless construction. In this type of construction, there is no frame and there is no need of heavy side member. That is, the side members are eliminated and all mechanical components are attached directly to the body. These body are made up from pillars, rails, seals and panels, all welded together, and reinforcing channel section under frame with extended subframe at front is provided to replace the chassis. In case body shell and underbody are welded together into single unit, the underbody is made up of floor plates. This construction gives more strength and rigidity. The chassis, floor and body are assembled by welding from a large number of mild steel pressing. This design reduces the vehicle weight, decreases cost, improves fuel economy, but increases the repair cost, duration and accident. This assembly replaces the frame and decreases the overall weight to the conventional frame and body. Integral body construction is used in passenger cars as it has advantages such as last longer owning, that is increased beam strength, adequate torsional stiffness, require fewer parts, involves fewer assembly operation, more economical weight reduction, that is more economical, reduce weight, improve fuel consumption, longer life, and in integral construction the reinforcing members are provided below the floor, so it does not occupy the space. So this is it. Thank you for today's session. We have completed what do you mean by chassis, its function, its requirement, and what do you mean by frame, its function, its requirement, and the types of frame. Thank you.